wait and do the targets for 2100, 2150. I think the time is precious and of essence. And this is here, I'm taking most of the data actually from these bodies that made the studies, and we see that this is how much carbon is pumped into the atmosphere by the end of the year. That's 30 billion tons of carbon, and that will produce a CO2. As we speak, the CO2 right now is actually a little higher. This was taken about 10 days ago. It's a little higher than 388.79, and it was down here. It was somewhere in the 1900. It was around 290 or so, and therefore it keeps rising. This one is from Monroe, and you can see it's rising here. This is here Kyoto, and the curve keeps rising and exponentially actually. And I don't think it will change, it will bottom down, it will stabilize after. There is no way that will stabilize, no matter how many changes we made by conservation. What do you say, conserve? What are you going to do? You're going to improve efficiency, but your consumption of energy is going higher, so you're going to make efficient machines that will give you higher efficiency, but still, these are marginal improvements actually, unless a drastic solution is done. And therefore, there is no room for improvement as far as the time is concerned. Now, if we go to desert heat conversion into electricity, actually we'll probably top down by the year 218, 219, and that will be our maximum height. That's 410 ppm, and that's around 32, 33, 35 billion tons, and that will start going down. And here what we're doing is we're phasing out fossil fuel energy, and we are phasing in desert heat electricity, and it will be generated on a global scale, and we have reserves, and we'll talk about them later, reserves that will go for until it's eternal reserves actually. And therefore, this is the road back to 1750. By the 2070s and the early 80s probably, we will be at the station of 1750, at 280. At that time, the budget will be balanced. There will be zero surplus of carbon dioxide and zero deficit of oxygen. And then the nature will go back to its old ways of dealing with matters. If we don't do that, now this is the curve shooting up. And now yesterday we heard people talking about 550. Well, if we have problems, now we are in 388 and we have lots of problems and lots of human environmental refugees and disasters, and these are only the consequences and the science of the problems. We don't know exactly what's cooking behind the walls, and therefore I don't know if we have time to wait even for 480 or 500, let alone the 550. This is quite high. I mean now we have problems between 280 and started in the 60s, I think, when the 75 and 90, when they started talking about global warming and about the meeting of the G8. It was at that time, it was about 360. That means they envisaged the problems then. Now it's 388, so the difference actually is about 108, and we have already problems. What if we have about 200 ppm more? It's definitely it will be. I don't think we want to wait until that day, or wait until the day when we see a city says that about 20 kilometers away in the sea, that was the center of the city about 50 years ago. So this reading was taken about a week ago, and you can see that there is quite a lot of difference. 300, this is 104, and you look down now, it's 397. So you got already about 2 billion more of carbon dioxide in the air. And this is the curve. It was nicely and smoothly going throughout the years until here in the late 1800s, it starts to climb. And it's going to go on like this. So, okay, now these are facts. We just want to reinforce what we said about carbon dioxide, that it has to go, it got to go. The natural balance in 1750 was 2.2 trillion tons at that time, and this is the concentration in the atmosphere. That's the healthy concentration that we'd like to go back to. And the net atmospheric CO2 then was 0, as we said, and the atmospheric CO2 in 2009 right now is 3.05 trillion tons and rising by about 1,000 tons a second now, and it's increasing by about 5% per year. And now surplus CO2 that should be removed, we're talking about 855 billion tons. Now people talking about capture and storage. How are you going to do that? When you take 1 liter of oil, it was occupying 1 liter of space in the reservoir, and then you burn it. You get 2,000 liters of carbon dioxide. Now you put it back. You're going to put it back 1 liter under standard pressure. And then are you going to pressurize it again into the system? So this is totally a reactive approach, and we should talk about proactive approaches. So storage and capture and storage is actually no action, and it proves to be highly costly. And I don't know if we find the space under the ground, the salt mines or the depleted reservoirs. This is, I think, that should be carefully studied. But and we have CO2 emitted in 2009, like 30 billion tons. By the way, that's not only from combustion. We have about 20% from associated carbon dioxide that comes from the reservoir with gas, associated with gas and oil. So if you improve the efficiencies of the mechanical systems around the world, there is no way that you can prevent that 20% of associated carbon dioxide unless you do capture and storage, like many companies are thinking of this reactive approach. Now, net atmospheric CO2 surplus in 2009 is 17 billion tons. The CO2 removed in 2009 is 13 billion tons, and that's a pretty good one. Atmospheric, now we have a zigzag. Sometimes it removes, the removal is higher, sometimes it's less, so depending on the seasons, the seasonal changes of during the year. Atmospheric CO2 clouds are thickening and may sink to the ground surface anytime. We are running out of oxygen. In 2009, 22 billion tons and going to 2 billion tons, that's daily, I think. Freshwater supplies are dwindling, food is in short supply, energy in crisis, and by the way, the financial crisis and all the crises that we have, especially the financial crisis, I don't think I see that they'll be resolved because they're all spinning around energy, and energy is the issue. So how they're going to fix the economy or get out of the recession, I guess the energy situation and energy security has to be resolved first. Now, these are statements I'd like to go through, if you don't mind, by key personnel, and they are calling for the same thing. I've taken this from the CP, that's Copenhagen 15 Thinkers blog. And here it says a statement of, these are statements of urgency, I think. This one is from the IPCC. And here, the truth about climate change in June 1995, the academics of science of the world's 11 largest economies, G8 plus India, China, and Brazil, urging world governments to take urgent actions to address climate change. And this is by John Theodore, and he's from the IPCC, as I said. And the other one, let's make peace with the planet we live on. Today we are faced with several major global challenges which no single country can solve alone. Climate change and the economic crisis do not recognize national borders. So, for the only way the world can tackle them is by working together. And this is from the President of the European Parliament. And working together now, we're talking about desert heat. Actually, the whole world system has to change.